You know, right now, inside your own head, there's this incredible underdog story playing out. We're going to dive into the brain's forgotten pathway for movement. It's this backup system that has a really remarkable story of, well, both distress and resilience.
All right, so let me ask you this. What if your brain's main system for controlling your body just went offline? Is there a backup? You know, like an emergency generator that kicks in when the power goes out? Well, the answer is a big yes, and its story is pretty wild.
Okay, but before we get to our underdog, we've got to talk about the main event first. The undisputed champion of movement. I'm talking about the brain's motor superhighway.
So picture this primary route like a massive 8-lane superhighway. It is fast, it's incredibly efficient, and it's carrying almost all the traffic, the signals that let you do, well, everything. Walking, talking, typing, all of it.
This superhighway has a name, of course. It's the corticospinal tract. And what's cool is that it's a pretty new feature, evolutionarily speaking, and it's super developed in us humans. It's in charge of all our muscles, the ones that bend our arms and the ones that straighten them out. It runs the entire length of the spinal cord, which is what gives us that amazing, precise control you need to, say, write your name or play the guitar.
All right, so now let's turn our attention to the real star of today's explainer. If the corticospinal tract is that gleaming, modern superhighway, then this next pathway, well, it's the old forgotten country road that runs right alongside it.
So, say hello to the rubrospinal tract. This thing is ancient, way more primitive. And while that superhighway is handling all the heavy traffic, this old road has just been kind of quietly waiting in the wings, serving a really specific and, as we'll see, sometimes absolutely critical purpose.
Its journey starts in a part of the midbrain called the red nucleus. And no, that's not just a fancy name. In fresh tissue, this little spot literally looks red. That's because it's packed with iron and has a super rich blood supply. Pretty cool, right?
So, the path this tract takes is actually pretty simple and direct. It kicks off in the red nucleus, but then, and this is a key detail, it immediately crosses over to the other side of the brainstem. That's super important. It means the right red nucleus controls the left side of your body, and the left one controls the right. From there, it travels down and then just stops in the upper part of the spinal cord. That's our first big clue that it's mostly focused on controlling the arms.
Okay, so what's this ancient pathway actually do? You know, on a normal day when everything's running smoothly, what's its regular 9-to-5 job?
Well, its main gig is all about the upper arms. Its number one command is to fire up the flexor muscles, think your biceps, while at the same time telling the opposite muscles, the extensors, like your triceps, to just chill out. So literally every time you bend your elbow to pick something up, this little pathway is in on the action.
And this is really where you see its underdog status come into play. See, in other mammals, this tract is a major player. It's critical for how they move. But in us humans, as our big, fancy cortex and that superhighway evolved, the rubrospinal tract kind of got pushed to the side. It's still there, for sure, but its role became way more specialized.
But this is where our story takes a really dramatic turn, because sometimes that old country road is the only path left open after a catastrophic pileup on the superhighway.
So just imagine a severe brain injury, something that damages the higher brain centers and basically cuts off the connection to that powerful corticospinal tract. Poof, the main route for movement is just gone. So what happens now? Where do the body's motor signals go? Is there any other route?
Yeah, the ancient pathway takes over. The rubrospinal tract is still there, it's totally intact, but now it's running wild, with none of the checks and balances from the main system. And its out-of-control signal creates this really dramatic and very specific sign the doctors can see. It's called decorticate posturing. And for neurologists, it's a huge red flag that indicates very, very serious damage to the brain. What you see is the person's arms bending stiffly inwards, their fists are clenched, and their hands curl right up towards the core of their body.
Okay, so here's the crucial part. The injury happens above the red nucleus. So our little ancient pathway is totally fine. It's undamaged, but it's also completely uninhibited. Its one primary signal, flex the arms, is now just screaming on a loop. And that's what leads to that tight involuntary flexion. It basically becomes a distress beacon, telling doctors exactly where the damage is located.
But this pathway isn't just about being a distress signal. In situations like stroke recovery, it can actually step up and play a much more heroic role. It reveals this incredible story of the brain's resilience.
See, when a stroke damages parts of that motor superhighway, the brain shows this amazing ability to adapt. We call it neuroplasticity. And our underdog, the rubrospinal tract, can actually start to take on some of the jobs that were lost. It steps in to act as a kind of compensatory pathway.
And this backup system can make a real difference. Research suggests that when the rubrospinal tract kicks in to help out, the recovery of motor function in the upper arms can be significantly better than it would be otherwise. It gives a genuine boost to the whole recovery process. Now, we have to be realistic here. This old country road was never designed to handle superhighway levels of traffic, right? So, while the help it provides is significant, and I mean, it can make a huge difference in a person's life, it's not a perfect replacement. That really fine, skilled control that the main system used to provide, that often doesn't come back completely.
So after this whole journey, what's the big takeaway? What's the lasting legacy of this tiny, ancient, and so often overlooked pathway?
Well, when you put them side by side, the two main characters in our story become crystal clear. You've got the ancient, rudimentary, old road, that's our rubrospinal tract, and it's focused pretty much just on the upper arms. And then you have the modern, highly developed superhighway, the corticospinal tract, that's in charge of the whole shebang. One is a specialist, a backup player. The other is the dominant force, no question. And that leaves us with a really fascinating final thought to chew on. If this ancient pathway has this built-in, natural ability to step up and help, well, could we find ways to intentionally activate it? Could this underdog, the same one that can be a sign of devastating damage, also hold the key to new therapies? Therapies that could seriously improve recovery after brain injury and stroke? That's the big question, and you can bet researchers are working hard to find the answer.